to begin by acknowledging the traditional owners of the land on which we meet today, and also pay my respects to elders past and present. Welcome everyone to the CLEX seminar series. It's a pleasure to have Professor Andrew Weaver today. He's a professor in the School of Earth and Ocean Sciences at the University of Victoria, Canada. He received his bachelor in mathematics and physics from the University of Victoria in 1983, a master's of advanced studies in mathematics from Cambridge University, a PhD in applied mathematics from the University of British Columbia in 1987. He did a postdoc at the School of Maths at UNSW, so welcome back. He has over 200 peer-reviewed papers in climate, meteorology, oceanography, earth science, policy, education, and anthropology journals. He was also a leader author in several IPCC assessment reports, and he was also the Canada Research Chair in Climate Modeling and Analysis. So Andrew was among these scientific advisors who helped develop a number of climate change policies, including the introduction of North America's first carbon tax in 2008. In 2013, he was elected as a member of the British Columbia Legislative Assembly for Oak Bay Gordon Head. He served 2 terms. In 2017, he became a leader of the BC's Green Party. The election ended in a minority government with the Greens holding the balance of power. For his work developing BC's clean economic plan collaboratively with the New Democratic Party, he and the Minister of Environment received the 2020 Clean 16 and Clean 50 awards for outstanding contributions to sustainable development and clean capitalism in Canada. Andrew is a fellow of the Royal Society of Canada, Canadian Meteorological and Oceanography Society, American Meteorological Society, American Geophysical Union, and the American Association for Advancement of Science. He received a number of awards and fellowships that I won't list here. In 2008, he was appointed to the Order of British Columbia, and in 2014, he received an honorary degree from McMaster University. He has 2 books, one published in 2008, Keeping Our Cool Canada in Warming World, and the second one published in 2011, Generation Us, The Challenge of Global Warming. This is a very short introduction to Professor Weaver. He has an outstanding career that is worth reading from his website, so I'll put his website on the chat so you can have a look. There is also a documentary film called Running on Climate that talks about his election campaign 2013 and how he became the first Green Party member of the Legislative Assembly in British Columbia, Canada. And today is a pleasure to have him here. He'll talk about privilege, agency, and climate scientists' role in the global warming debate. Please put your questions in the chat, and remember there will be an ECR session after this in a different Zoom meeting. So with that, I'll just give you the floor. Please share the screen. I can start. Thank you.
Thank you. Thank you very much for that kind introduction. I just had a big smile to come to my face when I saw in the chat that Will Hobbs put up from what was the word? What did he say? From caveats to superlatives. A very good description of the IPCC journey that I know Andy's done as well, that I've done since the early 1990s to today. So what I'm going to speak about, and can I get confirmation you can see the screen?
Not yet, so you need to share the screen.
I thought I had. Clearly I hadn't. That's why I always ask confirmation. Okay. So it should come up now. Can I get confirmation now that the screen is shared?
That's working well. Thank you.
Perfect. Thank you very much. So I'm speaking to you from the University of Victoria, where I've spent much of my career, and I'm speaking to you wearing 2 hats. The first hat is as a climate scientist who's been working in this field since the mid-1980s, and the second hat is through somebody who ventured into politics for 7.5 years in an attempt to try and bring some civil discourse, and I meant civil discourse, on the climate file to the BC legislature. I ran with the BC Green Party because there had never been an elected member of any Green Party in any province in Canada before. And so I realized that I would not be kind of beholden to the kind of partisan history of a party with all its various elements, and I would be free to say what I believed was important on the climate file. And so I'll approach both of these and see if I can pass along some of the things that I learned in this kind of wearing these two hats. Well, the first thing I'd like to start, as I always like to start, is defining what is the problem. Well, we all know what the problem is. The world is warming. This is showing, as you've all seen from NOAA, the surface temperature anomaly relative to the 20th century average, showing that we've warmed by about 1.1, 1.2 degrees since pre-industrial times, despite the fact that 40% of Republicans in the US believe that there still is not solid evidence that the world is warming, akin to not believing in the existence of thermometers. Now, I suspect you have those same types of folk in Australia as we have it south of the border, as well as parts of Canada, where no matter what science is brought forward, really it's somehow not conclusive with respect to the human causation of climate change. And it's quite frustrating trying to convey the science when you meet this sort of resistance. We also know that if we look back in time, that essentially reading back the warmest years on record is like reading back a chronological list of most recent years, jumbled ever so slightly because of internal variability within the system, as you would expect, because the ocean makes up 72% of the surface of the Earth, and the ocean moves, and associated with that moving water is moving heat. And so rather than just seeing a steady linear trend, of course, we see internal variability in the system. Some of it is related to changes in the external forcing, but a lot of it is just internal dynamics of the climate system. And the ocean plays a key role in that regard, and particularly in its interaction with the atmosphere. So if we look, the world has been warming, but this year has been particularly odd. You're going to get it in your winter, or sorry, your summer. We felt the ramifications of the 2023 El Nino here in Canada as we had this typical response of dry and warm conditions. However, in this particular year, because of sustained drying and warm conditions, we shattered our forest fire record, just completely shattered it across Canada and in particular British Columbia. But we were not alone, of course. Events were happening in Europe. One of the most dramatic of those events is what went on with the Antarctic sea ice extent this year. I mean, it's like 5 standard deviations below normal, which is, again, really quite dramatic and remarkable. And now the community, as I'm sure you're aware, is Northern Hemisphere biased. So we've focused much of our attention, that's because there's more people in the North, nothing other than that. We've focused a lot of attention on the Arctic. And the Antarctic is busily going on its merry way, also responding to the increased warming. And in this particular year, the anomaly was quite stunning. And of course, as I mentioned, in this particular year in Canada, the forest fires were, I mean, it was something else. So I don't know what the forest fire response in places like Sydney are like, but here in British Columbia, you would have fog so thick, and it was fog of smoke. And it's just from forest fires in the interior of BC. Quite dramatic, very serious health concerns too. What was the response? What was the global response? I mean, the cognitive dissonance demonstrated this year is beyond stunning, in my view. The example that I used in this article for the conversation was as I was writing about the fact that temperature records were being shattered in July and August, the response in California, where all-time record temperatures in Death Valley were being set, was that tourists started flocking to experience the heat. And lo and behold, deaths started to occur accordingly. It was the same in Greece, in Spain, in Italy, as governments were warning people to stay away because of the intense heat. Tourists were flocking to experience the intense heat. It's an odd kind of cognitive dissonance that kind of permeates the kind of social narrative of climate change. Now, I'm going to put this figure up, and I like to put this up because I'm going to try to summarize what I believe reflects the whole issue of global warming and whether or not we as a society want to deal with it by boiling that down into a single question. That is summarizing everything we know about climate science, summarizing everything we know about climate solutions, and summarizing everything we know about political will, and summarizing everything we know about whether or not we want to deal with this. And that's illustrated through these panels here, which come from, I believe it's the 4th assessment report. And I keep putting them up because the figures are beautiful and they stand the test of time. What is shown here is, again, from the IPCC report, the response of the climate system as obtained through the average of many models. The numbers here are the number of models worldwide. Of course, you have models in CSIRO, BMRC would have had one in here too. We've got Canadian models, US models, etc. And it's shown in two columns. The first column is averaged over the decades 2016 to 2035, and the second column is averaged over the latter 2 decades of the 20th century. And there's 4 rows, and each of these rows provides the response of the climate system to forcing from various scenarios. The bottom one is so-called RCP 2.6, a relatively green scenario where everybody gets very keen about dealing with global warming and reducing emissions and taking us down to starting to introduce negative emissions, etc. 4.5, slightly more aggressive. 6 is a kind of fossil fuel intensive, kind of the one we're sort of heading towards, it seems. And 8.5 is a more fossil fuel intensive right the way to the end of the 20th century. And the reason why I think these are so important is that if we look at the first 4 panels on the left, each and every one of these has about 0.5 degrees Celsius warming in them over the decades 2016 to 2035 relative to the decade 1986 to 2005. So regardless of the policy decisions being made, the warming is essentially the same in these. And the reason why, of course, is because a policy decision can be made, but its implementation and the results on greenhouse gases does not happen overnight. For example, if you have a zero-emission vehicle mandate come to play, these are usually applied to new vehicle sales, so you need to turn over your capital stock in order to actually feel the full implementations of the policy, i.e. there's socioeconomic inertia in our built environment. You don't build a coal factory today. You seem to be building a lot of them in Australia, much to the chagrin of the rest of the world. We don't build coal today to tear down that factory tomorrow. And so the inertia in our system takes time, and as a result, really the warming in store that we're going to see is a result of past policy decisions in the couple of decades ahead. However, the decisions we make today have a profound effect on the warming towards the end of this century. The bottom is the very green scenario, and the top is kind of let's burn it all and keep on that pathway scenario. The response to ecosystems as well as to people would be dramatic in these cases. And herein lies the political conundrum. The people making the policy decisions today will not be around to be held accountable for the decisions they make, and hence they often make decisions far down the road, like nonsensical promises of reaching net zero by sometime mid-century, when of course everybody knows not a single one of the people making such pronouncements will be in the present role that they're in to be held accountable for not fulfilling their promise. Governments and politicians love promising stuff at 2050 because they're not going to be around for that. And invariably what happens in the political establishments is that, and particularly in first past the post systems, you have forms of proportional representation or preferential balloting in the US, in Australia, is you end up finding that brush fires that can be put out tomorrow are the kind of policies you focus on. Because when it comes to election time, you can accomplish your goals and point to the successes of your implementation of said policies and ask people to vote you back in. There's a reason why, I'm sure it happens in Australia, but it happens every election here in Canada, that political parties campaign, for example, to reduce hip and knee replacement lineups. Why are they campaigning to reduce hip and knee replacement lineups? Because in Canada, at least 80% of seniors vote. We know that the voter turnout with youth is between 35 and 45%, whereas 80% of seniors vote. And we know if you're living with, I just had a knee replacement, so I feel very comfortable speaking about this. If you're living with arthritic pain in the joint, you know how life-changing it can be to have that joint replaced. You can throw a bit of money at that problem, or reduce those wait lines. In Canada here, it's a year to get a hip or knee replacement, and point to that result at the next election and say, look, vote me back in. I listened to you. I've responded to you. You're getting your hip replaced. And all those seniors, that 80% of them who vote, are going to say, yeah, you did. I'm going to reward you for that. Whereas what about aggressive carbon pricing, policy measures for which there's some short-term pain perhaps, but certainly a lot of long-term gain? It's kind of hard to point to anything and say, look, this didn't happen or this did happen as a direct result of this climate policy. So climate change policies end up falling off the platforms of most political parties and campaigns because it's not a ballot box issue. Despite the facts that we, as members of the climate community, think that climate change is a ballot box issue, it isn't. It hasn't been in Canada. It really isn't anywhere, because people often think about what they need now as opposed to what they think they need a decade from now. So this boils down to the whole question. The whole question as to whether or not we as a society or societies wish to deal with global warming really boils down to one question. Do we, the present generation, owe anything to future generations in terms of the quality of the environment we leave behind? Yes or no? And now science cannot answer that question. And that's also very important for us to realize as climate scientists, is that while we have strong opinions on that question requires broader societal input. You might imagine, for example, that, and there are significant elements in the southern US and parts of Canada too, that you might imagine that in fact climate change is a manifestation of God's will. Now, I say that out of respect for religious faith-based belief systems, but you will know that each and every time faith trumps science. So if you believe as a matter of faith and that global warming is really a manifestation of God's will, taking us to Armageddon and the second coming, then it's very difficult to try to persuade someone of anything other than the fact that it is meant to be. So on the other hand, there might be libertarians in our midst who don't believe in worrying about the future because the future will take care of itself. What matters is the here and now. There might be people who don't have children, never intended to have children, and so really just care about what's happening in their life today. These are all stakeholders that the political establishment have to listen to because ultimately they're all voters. However, if we do believe that intergenerational equity is important, then we have no choice but take aggressive action today, because waiting to take action is too late. And the steps we take today require bold leadership, because those taking those steps will not actually be able to be held accountable for the consequences of them, because that'll play out in the decades ahead. So why do we care? Let's assume that we do believe that intergenerational equity is an important value that we wish to preserve. Well, there's two reasons to care about global warming, obviously, is the widespread species extinction. The rate of change of the climate system is much more dramatic than it's seen in the life of many of our present species, and they'll struggle to adapt. But from a human perspective, really the issue is geopolitical instability. What do you do with hundreds of millions of people who, through no fault of their own, are now experiencing the consequences of climate change created by other jurisdictions in the world? That sows the seeds of discontent, and that to me is a very big issue that is going to play out in the years ahead. All right, what is the scale of the challenge? I'm going to pivot back to some work that we did in 2007. That's 15 years ago. I mean, this is why this is very frustrating, spending your career as a climate scientist. And what I'm showing here is the results from a hypothetical policy trajectory, where magically we're going to start in the year 2005, and magically we're going to reduce emissions moving forward until by some percentage at 2050, and do no more from thereafter. So in the green curve here, we reduce emissions 20% below 2005 levels by 2050, keep it fixed. The next one is 40, 50, 60, 70, 80, 90, and 100% reductions at 2050. The reason why I'm putting this up is you can look on the right here as to what happens to carbon dioxide through the next few centuries, assuming that we're just going to take this policy step and stop at 2050. And what you find here, of course, is the levels are all going up, except in the case where we have 100% emissions reduction. And when we actually compute the temperature, and this is done in our UVic model that Katrin spent a lot of time working on, Katrin Meisner at USW. If we look at temperature, if we cut emissions by 90% at 2050 and do no more, but keep them fixed at 90% at 2050, we also break 2 degrees eventually too. So in many of these, there's a disconnect in many of these policy discussions that have been out there with people suggesting we need, sorry about that, is that we've known for a very, very long time that the only solution to ongoing warming is to actually get to net zero or total zero emissions of carbon dioxide. And the good news behind that is if we do the same experiments as I did in the previous one, but instead of stopping at 2050, but continuing down on the linear trajectory until such time as all emissions are gone, and if you come right down here, you can see, well, you can see the CO2 response to 0%, 100%, and everything in between. But here, if we look at the surface air temperature, we see that anything with about a 40% or more reduction at 2050 on the way to carbon neutrality linearly later that century actually keeps warming below 2 degrees. And the reason why I'm talking about the number 2 degrees is this is a number that's been bantered around within policy, UNFCCC, United Nations Framework Convention on Climate Change, policy discussions for many, many years. The desire, according to the Paris Agreement, is to keep warming substantially below 2 degrees. And clearly, and this is known since for more than 15, closer to 20 years, that means zero emissions. That doesn't mean 10% reduction or 20% reductions. It means we must go to net zero. And what net zero means is another interesting issue, because net zero doesn't mean that we can get there through planting trees. It means the complete decarbonization of energy systems and the widespread global introduction of negative emission sources to start sequestering atmospheric carbon dioxide that's present there already and sequestering it in deep geological reservoirs, or somehow magically creating, speeding up the process of chemical weathering. So this is a great big challenge that's before us, but it's not one that I believe it's one that we can meet. So in that article, that paper that we published in 2007, we stated that our results suggest that if a 2-degree warming is to be avoided, direct CO2 capture from the air, together with subsequent sequestration, would eventually have to be introduced, in addition to sustained 90% global emissions reductions by 2050. This was trying to inform the policy debate that was ongoing in North America at the time, where people were really missing the big picture. How have governments responded globally? Well, not well, frankly. I'm not sure if you have history of climate science courses at the University of South Wales now, but if you go back into the history of where our understanding of climate science comes from, it really all begins with Jean-Baptiste Joseph Fourier, who in 1824 was the first to recognize that the atmosphere acted like, was transparent to incoming solar radiation, but was very effective at absorbing and re-emitting back to the surface what was called as non-luminous heat or infrared radiation, keeping the Earth's surface habitable for us. Remarkable study by Eunice Foote. Many people, she didn't get the credit for this. It was John Tyndall with his crazy sideburns who got the credit for this. Eunice Foote published a very insightful paper pointing out that carbon dioxide, I don't know, it was 1856, carbon dioxide had different radiative absorption properties from water vapor, for example. That is, different molecules of different gases could do things differently. Anyway, the science continues to evolve, and emissions just keep going up as science evolves. Here we are at the Paris Accord in 2015, and we've just kept on going to 2023, where we are now. So despite the advancement of science going back for several hundred years, despite, as we were talking about, the elimination of descriptors like likely or very likely, and the addition of superlative like extremely and which has been happening through these IPCC reports, nothing's being done. I want to come to the Kyoto Protocol, because this is a really important piece of international policy that has been largely misunderstood and has not been celebrated for the incredible success of this protocol. In 1997, this was really the first attempt to get countries to agree to reduce greenhouse gas emissions. And as part of that attempt, Annex B, or so-called developed countries, of which Australia was included, Canada as well, European Union, etc., agreed to collectively reduce emissions to 5.2% below 1990 levels, averaged over the 2000 to 28 period. Canada set a target 6% below, and the US set a target of 7% below. 192 parties, and Canada, including Canada, Canada ratified the agreement, and we officially pulled out. I think Australia may have pulled out too, another embarrassment. Someone can confirm that with me, I can't remember, but Canada pulled out, the US never ratified, and it was a signatory, and they did pull out as a signatory in 2001. But let's take a look at this. So if we look in the average over 2008 to 2012, that was the reporting period for the Kyoto Protocol. So the Kyoto Protocol, the commitment was to reduce collectively 5.2% in Annex B. Those are the developed nations. And the understanding of the Kyoto Protocol was the developed nations would show leadership, start the reductions. And in the second reporting period, the next phase, the developing nations would come under the umbrella and also start to reduce emissions. It was an approach to global equity that was supported by many. So here's what happened in Canada. Average over the reporting period, we said we go 6% below, we were 16% above. Canada equals #fail. Here's the US, 6.7% above in 1990, like they said, the 7% below. US response, #fail. Japan said they would be I forget what they said they would be, they were 4.3% above. And now let's start to look at some other jurisdictions. The UK, 24% below 1990 levels, averaged over the reporting period. Germany, 22% below 1990 levels, averaged over the reporting period. If we include every nation that was included in Annex B, including Canada and the US, the Annex B nations, including Canada and the US and their woeful track record, collectively reduced emissions to almost 10% below 1990 levels in the reporting period. That almost doubled the global goal. So the global goal was 5.2%. The global response was 9.9%. And if we throw Canada out and the US out as the rogue nations that we were in this, it would be 20% below 1990 levels. The UK is something like 40% below 1990 levels now. So despite what you'll hear, despite the, Kyoto is going to create job losses and the world's going to end, it was an incredible success. But no thanks to Canada or the US. I didn't want to insult Australia, but to be blunt, you weren't very helpful as well, with respect. So you could imagine the scale of frustration for someone like me, who has been working in this space since the 1980s, and serving as a lead author on the second IPCC assessment, the third IPCC assessment, the fourth IPCC assessment, and the fifth IPCC assessment, which was this one here, Climate Change 2013. And in all of these, I was typically involved in the Projections of Future Climate chapter. And if we then want to summarize this, and so in 2012, we're writing our reports. When this appeared, really, it was a big downer for me, because you could really summarize everything in this literally 1,000-page volume, one of 3 volumes for the IPCC, as more of the same with greater certainty. Added a few superlatives, removed a few descriptors. And in 2021, to be blunt, with great respect for the scientists who spent an awful lot of time working on these, and I know how much time is involved, it's incredible workload. I would argue it's the same thing. Essentially even more of the same with even greater uncertainty. And this starts to become somewhat problematic, because governments are always looking for reasons and means and ways not to do anything. And when you're waiting for reports to tell you how uncertainties are reduced, you wait until said reports are published to respond to how those uncertainties have been reduced. So I'm at this stage beginning to question whether or not we continue the need for these incredibly comprehensive reports. They're great for learning and teaching, but at some point, one might argue that they're becoming an impediment to the advancement of policy because nothing is being done. So I graduated from high school in 1979. In 1979, that was the year that the very first national assessment was done. It's called the Charney Report. It was done by Jewel Charney and a group of Woods Hole and MIT scientists and others who sat around and were tasked with assessing the scientific basis for projection of possible future climate change resulting from human releases of carbon dioxide into the atmosphere. Well, in that report published in 1979, climate sensitivity, the single most important metric, I would argue, summarizing our collective understanding of feedbacks within the climate system, was estimated as somewhere between 1.5 to 4.5 degrees, with the central best estimate of 3. Climate sensitivity, by definition, is the amount the world would warm as a direct result of doubling carbon dioxide levels from pre-industrial value of 280 to 560. So in 1979, the best estimate summarizing all the previous literature was between 1.5 and 4.5 degrees. Svante Arrhenius actually was the first to come up with an estimate of climate sensitivity in the 1800s, late 1800s. His was a little higher, but if we start getting into the international assessment process, in 1990, we got the first the first IPCC report. And in this report, climate sensitivity was estimated between 1.5 and 4.5 degrees. That's, not too long, 11 years after the Charney report, not too long, hasn't changed much. Second assessment report, 1995, unchanged. Third assessment report, 2001, unchanged. Fourth assessment report, massive hoopla. We've narrowed the range until the fifth assessment report, when it went right back to 1.5 to 4.5 degrees. Now, as a climate scientist who's been working in the field, my entire career from graduating from high school to 2013 has been bookended by an invariant estimate of climate sensitivity, which is the single most important metric summarizing our collective understanding of feedbacks in the climate system. Like, do we need more science to tell us what the problem is? Do we need more science to tell us what the solution is? To me, it was clear at this stage that what is needed is political will, because we've actually been saying the same thing for a very long time. Now, I recognize that there were advances in the 2021 report, and good on them. I don't think anybody would have accepted the climate sensitivity range coming in at 1.5 again, and that range has been tightened slightly. That's actually a novel advance, although the best central estimate still is unchanged from the original 1979 estimate by Jewel Charney. So in 2012, writing this 2013 report, I have argued, and I began to reflect upon the fact that I think scientists have largely done our job in this problem. Obviously, there's nuances. We have to understand impacts. We have to understand various processes. Cloud physics is not going to be solved tomorrow. There's lots of really interesting science that needs to be done, and lots of really interesting science at the cutting edge between various disciplines, the intersection between the biosphere and the hydrosphere and things like that. But the real question is the world going to respond to this? Now, I actually I've been speaking about climate change for a long time. I never had this last line in there, but I do believe now, or they are just starting to. That's a recent change, because for the first time in my career, I'm actually beginning to see some developments nationally and internationally advancing solutions on the climate file. People are beginning to wake up. Back in 2012, this was not the case in Canada, when I felt that I could continue to sit around and just complain about the woeful lack of leadership on this file, or get engaged in our democratic system to try and make a difference. My decision was, okay, do I work more on the Navier-Stokes equations, coming up with climate sensitivity estimates, or should I throw my hat in the ring? And I did. And it was successful. And one of the reasons why it was successful is because of the messaging that was done in the campaign that didn't focus on the problem, but focused on the opportunity. And if one of the theses I'm trying to get across in this lecture is that as a community, we have agency in the global warming problem. We've defined the problem. We understand how it's going to manifest itself. We know what some of the uncertainties are. Who better than the scientific community to inform on the scale of the challenge and turn that in to the scale of the opportunity that global warming is presenting itself for economic and social and environmental prosperity if we actually deal with it. So I, in the campaign, and I continue to this day, argue that climate change actually is providing the world the greatest opportunity for innovation, creativity, and economic prosperity that the world's ever seen. It makes the industrial revolution of the 1800s pale in comparison, because we're really talking about transforming energy systems globally, all of them, in a relatively short period of time. A massive challenge, but an incredible opportunity. And opportunities for innovation are exciting because you can see every environmental challenge through one of two lenses. The lens of hopelessness and despair. It's too big. I don't know what to do, hopeless, or I'm part of this problem. I have agency in this problem. What an opportunity for innovation. Let's focus on that. And so rather than dwelling on the hopelessness, I actually believe we should continue as a community to focus on the development of solutions. And I'll come more on to that later. And the opportunity for innovation comes in two different areas. Obviously, decarbonization of energy systems is critical, but also the creation of negative emissions, which are required. Those are emissions that will take existing carbon out of the atmosphere and sequester it long-term. Now, I add a cautionary tale to the words nature-based, because again, I've seen an emergence of problems in this area, whereas governments looking to be seen to do things now are really beginning to get very excited about nature-based solutions. These are things like preserving eelgrass in oceans, saltwater estuaries, or planting trees. Now, you don't have to even do the back of the envelope calculation to know that that ain't going to solve your problem. We know since pre-industrial times, about 1/3, slightly less, of historic carbon emissions to the atmosphere have come from land use change, deforestation, land use change, etc. But the remainder is coming from geological carbon that was sequestered in fossil reserves over the time frame of tens of millions of years. And you're not going to draw that down by planting some trees and planting some kelp and some eelgrass. So while nature-based solutions have an important role to play, in fact, you might argue that they could provide 1/3 of the solution. The danger, and it's a very real danger, is that governments are now turning to these nature-based solutions and using them as a panacea, as the solution moving forward, because it's really easy to throw some money at planting trees. And it's much more difficult to start to stand up to the oil and gas sector, who are lobbying for increased incentives for increased continued use of carbonized energy systems. We know the solutions to this problem, they all exist. It's not as if we have to rediscover the wheel. They fall in three categories. They fall in technological, these are widgets, windmills, solar power, etc., electric cars, widgets. Behavioral, human behavior. This is one of the things that I think also differentiates the climate problem from many other social issues of today, and I'll cover that later, just towards the end, is that we often think that the climate problem is like other social problems, where we require governments to show the leadership. But I would argue that each and every one of us is part of the problem, and therefore each and every one of us is also part of the solution. The third are market instruments. These are the carbon pricing, et cetera. And the reason why I like to bring in market instruments is it's beautifully illustrated through the tragedy of the commons. Let's suppose, hypothetically, that we're back in jolly old England, and there's the Crown land, and this happens in BC too. Farmers are allowed to graze on the Crown land, and there's no cost, and farmers just do cost-benefit analyses and figure out, should I put another cow in line? And so you can imagine is if this Crown land and farmers are grazing their cattle, or all they have various branding on them, so you can determine which is yours. You might ask, do a cost-benefit analysis and say, well, look, this Crown land, should I put another cow on? Well, the benefit of putting another cow on that land is going to be reaped by me, 100%. And any costs of overgrazing are going to be distributed amongst everyone. So it's always to a farmer's advantage in the case of the commons and allowing cows to graze on the common to put another cow on the field, because the costs are distributed and the benefits are exclusive to me. It's the same as if you have a lake. In Canada, our lakes are publicly owned. So the fish in the lake are publicly owned. If you apply this directly to pulling fish out of the lake, it's to every fisher's advantage to take as many fish as they can, because they reap the benefits themselves, and any consequences of overfishing are distributed amongst all fishers. There's only one solution to this, and that's a collapse. And frankly, that's the trajectory that humanity is heading on, unless we actually start to deal with this problem. But how do we deal with this problem? In the commons case, it's quite simple. You elect a council, and that council has one of three policy tools that it can use. It could regulate the number of cows a farmer's entitled to put in, and say, we know the land can hold 100 cows, and we're going to create a regulatory environment that lets these people have that many, them have that many, et cetera, et cetera. That's heavy hand of government in heavy regulation. Government could cap the number of cows and say, yeah, we're gonna let 100 cows go on this land, and we're gonna let the market determine how much it costs to put a cow on the land. You can auction off permits, for example, to have a right to put a cow on the land. So the market's going to determine the price. You're going to have cow certainty. You have certainty as to how many cows are on the land, but you don't have price certainty. You might even allow farmers to buy and sell permits amongst themselves. And of course, you could put a head tax on a cow as well. And in the head tax case, you can control the number of the cows by raising or lowering the tax. If there are too many cows on the land, you jack up the tax. If there's too few cows on the land, you lower the tax. So you have price certainty here, but you don't have cow certainty. So obviously business likes the third one because they want price certainty, whereas the environment cares about number two, which is the cow certainty. Now, the analogy to the climate system is direct and one-to-one, is that the means and mechanisms we have to correct the tragedy of the commons is through emissions pricing, because right now it is in every person, in every household, in every municipality, in every town, in every city, in every province, in every country in the world's interest to do absolutely nothing about climate change, because any cost of action would be borne by the individual, and any costs of inaction are distributed amongst 8 billion people a couple of generations from now. It's kind of the mother or father of all tragedy of the commons. And so what would happen in the case of the commons is that you could elect, the regulatory governance structure to put in place the various policies, and they'll bring some money in, and they might use the money they might give it back through a dividend, or they might buy some fertilizer, or they might put fences up. It's the same in the climate system, is that through carbon pricing, carbon regulation, or through cap and trade, governments have tools at their disposal to actually put a price on emissions so that there's a real cost to using the atmosphere as an unregulated trash can. Whereas right now, anyone can put anything they want in the atmosphere, and there really are very little consequences to that. And that's not right. Look, when I was in university, we didn't have wireless technology. We didn't have cell phones. We didn't have laptops. My first computer was a paper tape reading machine. Actually, it was even before that. It was punch cards and switches. Now everyone in the audience probably has a laptop with them. We've put men on the moon. We haven't put women on the moon, not because we can't, because they're too smart to go there. We put men on the moon. And why did we do that? We did that because in 1962, John F. Kennedy stood up at Rice University and said, we're going to, because it's hard. And because of the challenge that the Soviet Union at the time had issued by being ahead of the US in the space race. And America wanted to remain the global superpower, and was a fear of losing it. There was political will and societal will, and within the decade, they put men on the moon because they wanted to, and it was hard. I challenge you to think of any piece of technology that really has remained invariant since its first introduction, other than the internal combustion engine. Okay, of course we have more efficient engines, we have catalytic converters, we have all sorts of change. But really, we are talking about a technology that caused pistons to go up and down through explosions, putting out noxious fumes. Like, this is not advancement. And you might wonder whether or not the reason why we haven't moved forward from this is because there are vested interests which are providing resistance to the energy transition. Because in doing so, they might suffer. Their kind of business model may have to change. So I would argue this is the barrier. The barrier is not the lack of solutions. The barrier is political will and influence peddling through various vested interests that like to maintain the status quo. Here in BC, when I got elected, we focused and developed something known as Clean BC, which is our climate plan here, designed to reduce emissions by 40% by 2030 and take us down to carbon neutrality, I think, at 2040. I'll believe the latter when I see it, because I'm not in the ledge to nip at the heels of the people not actually following through. And it was relatively straightforward to come up with a trajectory to get those 40% emissions, because in British Columbia, 38% of our emissions come from the transportation sector. So right away, if we could decarbonize our transportation sector, we're looking at 40% of emissions. So one of our flagship proposals we brought in was a very, very aggressive zero emission vehicle mandate. And this is a funny story. And this is exactly what one has to deal with. It's a true story. When I went into negotiations to bring in the zero emission vehicle mandate, there was a ton of resistance by the government, the NDP government. They finally begrudgingly agreed to have a 5% of new vehicles be electric by 2030. That was their negotiating position. I laughed. I completely laughed. It was ridiculous. And in the end, I forget the exact number. In the end, we've now banned the sale of any ICE vehicles by 2035. But the starting point was one of great resistance. Why? Twofold. Number one is fear about making people upset, fear that this might affect re-election. Also, lobbying. Guess who's lobbying to not bring in the zero-emission vehicles? Well, Honda and Toyota, both of whom had decided that in their R&D investment pathway, they were going to go all in on fuel cell technology and bypass the EV technology, wanting to take great global leadership in the fuel cell technology. Well, that's a corporate investment decision. So when I'm getting lobbied by representatives from a sector that made a corporate decision to invest in a different R&D, I called them out on this. But not everybody would be realizing where they're actually coming from. So there was resistance from the car sector, not from Nissan, obviously, the Nissan Leaf was one of the first, but from, say, Hondas and Toyotas that made the R&D path down the hydrogen fuel cell. So we know, for example, that the world has warmed by about 1.1 to 1.2 degrees since pre-industrial times. We know that permafrost carbon feedback is going to add another 0.1 to 0.2 degrees this century on top of that. And we also know that if we immediately eliminated all fossil fuels everywhere in the world, every human being died and fossil fuels stopped being emitted. Well, what would also stop being emitted are what are known as aerosols. And those are cooling agents that are also associated with combustion of fossil fuels, as they would dissipate through gravitational settling and precipitation scattering. And what this means is, if you look at coming out of the last IPCC report, the cooling here from other human drivers, largely associated with sulfur dioxide, and to a lesser extent others, eliminates out when you stop combusting fossil fuels as well. And the atmospheric lifetime of these agents is very short. The atmospheric lifetime of the greenhouse gases is longer. So we'll add another half. Let's suppose we immediately eliminated all combustion of fossil fuel. You get another half-degree warming that'll emerge because you've eliminated a half degree of cooling. So really, we also often talk about CO2. CO2 is 400, I said 420 now. I have 417 up there. But actually, CO2 is but one greenhouse gas. CO2e, that is, if you take all the other greenhouse gases and then roll them into a CO2 equivalent, is actually 523. So we're way past 1.5 and 2 degree kind of thresholds. We're pushing 1.7 to 1.9 going to happen this century, likely 2 or more. So frankly, I think that we need to stop fooling people and telling them that we're going to somehow keep warming to 1.5 degrees or keep warming to below 2 degrees. Because reality is, in my view, based on socioeconomic inertia, based on political inertia, based on the technology, the rate of technology replacement, is that we're really talking about 3-degree warming, which will have profound effects. But again, there's nothing magic about these round numbers. And in fact, the 1.5-degree warming, the story behind that is, I'll cover in just a sec. It's quite disturbing how that took off. And it took off through the Paris Agreement, which was designed to hold the increasing global average temperature to well below 2 degrees, pursuing efforts to limit the temperature to 1.5 degrees. The day this was agreed to, it couldn't be met. It couldn't be met for multiple reasons. Number one is the key negotiators are actually not in the room. That is the World Trade Organization, which is in charge of anti-dumping legislation, anti-dumping rules, etc. Is not in the negotiations. So the whole notion of what are called border tax adjustments still hasn't been resolved. That is, if there's a jurisdiction that's getting very aggressive in terms of carbon pricing, and there's a rogue jurisdiction that's not, the example I like to use is in Canada, we grow a lot of apples in the interior, and in New Zealand, they grow a lot of apples. If Canada we have aggressive carbon pricing. New Zealand may not, I don't think they do. So New Zealand apples in your Southern Hemisphere fall could be dumped on the Canadian market substantially below the apples that we would sell from Canada that had to be kept cool using energy to our spring, your fall. And that's not fair to our local growers. So we would want to be able to put the equivalent carbon tax on our border for the imports coming in from, say, New Zealand to ensure an equitable trading conditions. But of course, as soon as we did that, we'd get taken to the World Trade Court and it would be deemed to be not allowed. That still has to be worked out. And that really, because one of the flagship policies has to be carbon pricing, to internalize the externality associated with our behavior. If every country met its emissions reduction that they promised through their NDAs to the UNFCCC, we'd soar past 2 degrees. And this is telling me, and I think it's telling others, that we need to start investing in negative emissions technology now. I want to come to this 1.5 degree report, and I apologize to anybody in the audience who may have been an author on this. But I describe this report as hopelessly naive and very damaging to climate communication. Hopelessly naive is as follows. 1.5, the 2 degree number was pretty much held around, and it goes back to the European Union in 1988, where they made an error in climate sensitivity and said, we want to keep to 2 degrees. And so 2 degree numbers been around in Copenhagen Accord and all these other things. The small island nations were very unhappy with 2 degrees because they suggested that it would mean that they were committing themselves to destruction through sea level rise. And they lobbied for it at the UNFCCC for 1.5 degrees. They didn't realize that they'd still be underwater with 1.5 degrees, but that's irrelevant. Then nations like Canada and others became allies and started to support the calls from the small island states to actually get warming down to 1.5 if we could. And so they passed the language that talked about substantially below 2, pursuing 1.5. And then there was a bit of what did we just agree to? So the UNFCCC and government agencies tasked the IPCC of putting together a report outlining pathways to keep warming to 1.5 degrees. IPCC are made up of scientists. The governments provide the insight or the instructions. The scientific community writes it. The scientific community dutifully responds by producing beautiful pictures like this shown here, outlining pathways to keep warming to 1.5 degrees. And if you look at them, they're all talking about immediately reducing emissions and then introducing widespread negative emissions using technologies that haven't been introduced, don't exist at present, and would have to be scaled up globally. So obviously there's uncertainty in this, but that was all lost. And it was lost by the messaging that came out of that, where we started to hear The Guardian, for example, saying we have 12 years left to limit climate change catastrophe. We had global warming clocks being developed, counting down to the doomsday. And we had
Andrew, sorry to interrupt. We are
Yeah.
just getting to the end of this section.
I'm going to be another 5 minutes or so, because I'm just finishing off now. So but unfortunately, it's also has done a great disservice, I would argue, by feeding through climate communication widespread climate anxiety. Which brings me to the point of this talk, is that I believe that our community, with our privilege and agency, have a burden of responsibility to no longer scare people. We know what the problem is, but to identify and implement solutions, and no longer just spend our time describing the problem. Okay, I'll move. These solutions come in a variety of ways, and direct air capture is something that I'm working on with ocean thermal energy conversion as a source to drive the direct air capture emission reductions. But the key thing here is that I believe we've reached a tipping point in public opinion, is that that there is a desire for substantive action to reduce greenhouse gas emissions. I think we can thank Greta Thunberg for that. And in Vancouver, it made discussing climate change a social norm. And we had lots of support to advance climate solutions. However, we have to be very careful. We have to be very careful because there's a lot of negativity. There's a lot of people who are essentially shouting at the clouds, calling on governments to take steps, yet not willing to take a look at the mirror themselves and the way that they're contributing to the overall problem. What we actually need is people to recognize that if we work hard to change it, we can actually change this. We don't need people saying the world's doomed, because what that ends up doing is it ends up turning the average person that shovels them along into the "there's nothing I can do about" despondency phase. So in summary, I truly believe the focus moving forward needs to be on solutions, not yelling at the clouds. I could expand upon this and some of the tactics of the social movements of the 1960s that are being deployed by climate activist groups like Extinction Rebellion, which actually are doing more damage, in fact, than good. And I'll conclude with this, because I want to show you this video. And I want to end with this story. And this is a scientist. And I think you should be able to. I need to just make sure that you can, stop share and then share again. And I'm going to make sure I share the sound too. Share screen. Share sound. Screen. Boom. Okay, you should be able to see that. Can someone confirm? Yes. And I'm going to go to here. Andrea, could you see this?
Yes.
Okay, I'm just going to play this and then I finish off after this.
So I'm here because scientists are not being listened to. I'm willing to take a risk for this gorgeous planet, for my sons. And we've been trying to warn you guys for so many decades that we're heading towards a fucking catastrophe. And we've been being ignored. The scientists in the world have been being ignored. And it's gotta stop. We're gonna lose everything. And we're not joking. We're not lying. We're not exaggerating. This is so bad, everyone.
So the reason why I showed that is that person is a well-known climate scientist, clearly struggling with his own climate anxiety, believing as a means for himself to deal with his climate anxiety, he's communicating what he believes is the seriousness of this issue via TikTok. Now, who's the audience of TikTok? It ain't political establishment, it's kids. This video went viral, and I've been scraping kids off the floor for quite some time as a direct consequence of them seeing videos like this, where they start to see an expert standing up saying, in essence, the world's going to end. That isn't helpful. It's actually very destructive, and it actually is counterproductive to the advance of solutions, since, as I point out, all it's doing is shoving people into the "we're doomed and there's nothing we can do about it" box, when what we need is more people up here, and the future can be better if we work hard to change it. And I'll stop there and suggest that a more effective way forward for our community is, rather than shouting at the clouds, which people have been doing for a long time, people are aware of the problem now. We don't need to say what the problem is. What we need to do is assist governments advance the policy. Some of us might actually run for office. We need to advocate for solutions and point out the opportunity. And ultimately, the most important thing is demonstrate leadership through our own behavior and choices. And that is a huge problem, because every single one of us is part of the problem of global warming. And every single one of us, therefore, is part of the solution. But we need to recognize as a community, in my view, our privilege and our agency, and show the leadership we expect in others, not through crying and swearing, but by demonstrating the solutions that we would like others to adopt. And I'll stop there, and thank you very much.
Thank you so much. This was fascinating. We have a few comments in the chat, but we already over time. If anyone wants to have just a quick comment or a quick question, we can take one very quick, because there is a ECR session and that should be starting now.
Well, so I see Australia didn't ratify either. So you're in the rogues gallery as well, Australia. So well done. You can join Canada and the US. Nobody else has wrote a book. Yeah, Naomi's book is superb. I highly recommend it. Thank you, Matt, for raising that. Oh, okay, Julie, please, not another report. It takes so the thing about the IPCC reports, it also takes out the government climate scientists in the major climate modeling groups completely out of commission for quite some time. And it makes me concerned that we're going to have another one, but oh well.
I don't think that's been decided. It's just, I guess Sonia was out there saying there shouldn't be another report, and she's sort of changing her mind because she thinks without something regular from the IPCC, that would be worse, I guess. So it's still being decided.
But there could be reports. I mean, the way I would argue that the IPCC should move on is not these massive assessment reports, but thematic focused reports. You might, for example, solutions focus. Like, okay, everyone's going on about nature-based solutions. All right, go and write a report on that, because here's the type of stuff that drives me crazy. I have colleagues who are now advocating across Canada that what we should be doing is throwing calcium carbonate into the ocean, because if we do that, we're going to draw down carbon dioxide. I mean, nobody's doing the simple back of the envelope calculation, and it's really simple in that case. Is that in order to sequester 1 years of global emissions, we would need to ramp up calcium carbonate production. All limestone in the world, all production had to be increased by 80-fold. We'd have to immediately stop using cement everywhere in the world, no more concrete, and we'd have to take an 80-fold increase of limestone production and throw all that in the water and assume 100% efficiency in terms of drawdown. Like, it's just not going to happen. So rather than, I mean, these need to be called out for what they say with planting kelp and seagrass. Okay, great. They grow and they sequester carbon. But there's a very serious timescale issue there. And these are being bandied around in political circles by well-meaning scientists who are trying to get support for their research. But when you have government decision makers without any scientific experience hearing the kind of nirvana that will happen if you fund my pet project, they like to hang their hat on that, because it's a way of delaying doing the hard things that have to happen. Decarbonization, negative emissions, like geologically stored negative emissions, in my view.
Yeah, definitely. We'll leave the conversation there because I know that we're right out of time, but I could chat with you for ages about this.
I'd love to. Yeah, you were on the AR13, right? It was the
we were on the chapter together.
We were on the chapter together, in 2013 one. That was the going into the Hobart meeting when Australia climate sensitivity was 2 to 4.5 again. Coming out of the Hobart meeting, it was back to 1.5 to 4.5, right? So anyway, very frustrating.
Okay.
Thank you.
Thank you so much. We have to close this session, otherwise the ECR session will be too short. Thank you so much. It was a pleasure.
So Will just actually added a good point in there. I think Will's point is actually a good one. Really, I think there's still a need for WG2 and 3s, certainly on the 3s, and 2s to some extent, and 2 and 3 can be informed by 1. But we just don't need a 1,000-page report on the latest advances in cloud physics and ocean physics. Like, it's overwhelming amount of work.
All right. Thanks again, Andrew, and thanks everyone.
Thank you, Andrew. Awesome.